I'm Gokul. I'm going to solve this problem for the year 6303 probability and stochastic process class. So this is a question. We have p of x equal to k, which is equal to a into k of half whole power k minus 1. K varies from 1 to infinity. We need to find a, so that p of x equal to k represents a probability mass function, and then we need to find e of x. For this p of x equal to k to represent a probability mass function,
Pause. Stop.
as I was saying, for this function to represent it as a probability mass function, we need to show that summation k equal to 0 to infinity p of k is equal to 1. So this is what we need to show. And now p of x equal to k is given by a into k of 1 by 2 whole power k minus 1. Our k varies from 1 to infinity. So now I'm going to replace 1 by 2 with x. So it becomes easier for solving the problem. So we have p of x equal to k, which is equal to a into k whole power x whole power k minus 1. And now we need to perform the summation operation. So let us take a basic summation, k equal to 0 to infinity x power k. This is going to be equal to 1 plus x squared plus blah 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 to x power infinity, and which is in turn going to equal to 1 by 1 minus x. So now I'm going to multiply by a on both sides. When I multiply by a on both sides, we are going to get the equation in this form: a into x power k equal to a by 1 minus x. So now we need to get the equation in this form. If we perform the differentiation operation on this term, we will be on this x of k term, we will be able to get the equation in this form. So performing differentiation with respect to x, we are going to get k equal to 0 to infinity a into k x whole power k minus 1, and this side it's going to be a by 1 minus x the whole square. So this term is in turn equal to 1. So we have a equal to 1 minus x whole square, and we have x equal to 1 by 2. So a is going to be equal to 1 minus 1 by 2 the whole square, and a is going to be equal to 1 by 4. So the first part of the question is over. Now we need to find e of x. E of x can be given by summation of here we have taken the k to vary from 0 to infinity, but k equal to 0 is going to make the term as 0. So this is actually equal to this is going to be equal to summation k equal to 1 to infinity a of k x power k minus 1. So this is the final value we are going to get for the equation. So now let us go to the e of x part. E of x equal to, now we are going to have I equal to 0 to infinity xi p of I. So this is represents the e of x term. So p of x equal to k equal to a k x whole power k minus 1. So e of x is going to be equal to a k squared x whole power k minus 1. So this is what we need to find, and we know that from the equation which we solved earlier, summation of k equal to 0 to infinity a k x of k minus 1 equal to a by 1 minus x the whole square. So we need to get the equation in this form. So for that we need to multiply both sides by x. So performing the multiplication operation, you have a into k x power k, which is equal to ax by 1 minus x the whole square. Now I am going to perform the differentiation operation with respect to x on both sides. So we can see that we have got the e of x term. This term is equal to e of x, and we need to perform d by dx of ax by 1 minus x the whole square. This is a differentiation of the form of u by v. We know that d of u by v equal to v into u dash minus u into v dash by v squared. So let us perform the differentiation operation on this term. Okay, so d by dx of ax by 1 minus x the whole square, and a is a constant, I am taking it outside, so it's going to be x by 1 minus x the whole square. So this is going to be a into v is going to be 1 minus x whole square into 1 minus u into dv 2 times of 1 minus x into minus 1 by 1 minus x the whole power 4. A into 1 minus x is a common term, I am taking it outside. 1 minus x, it's going to be plus 2x by 1 minus x the whole power 4. A into 1 minus x by 1 minus x whole power 4 into 1 plus x.
Dot.
So we know the value of a is equal to 1 minus x the whole square. So it's going to be 1 minus x the whole square into 1 minus x by 1 minus x the whole power 4 into 1 plus x. So it's 3 times, and it's going to be 1. So it's going to be 1 plus x by 1 minus x. X is equal to 1 by 2. So we have this e of x is equal to 1 plus 1 by 2 by 1 minus 1 by 2, which is equal to 3 by 2 by 1 by 2, which is equal to 3. Starting up. And this is another problem. X is with fx of x, we have the probability density function, which is given by lambda into e power minus lambda x minus 1 u of x minus 1. We need to find the mean and variance of x. The mean of x is e of x, which is given by summation 1 to infinity. Taking into consideration this u of x minus 1 factor, we have x into lambda e power minus lambda x minus 1 into dx. You know that e of x equal to summation minus infinity to infinity x into fx of x into dx. So this is the direct substitution of that formula. And when you look at this term, 1 to infinity, lambda is a constant, x into e power minus lambda x minus 1 into dx. This can be solved by using the integration by parts mechanism. So, and the integration by parts is given by integration of u dv equal to uv minus integration of v into du. So we can take u to be x and dv to be e power minus lambda into x minus 1. So we can simplify it by this formation. So integration of u, which is going to be x into v. V is integration of this term. I did separately so that it would be easier to understand it. So this is the dv term. So v is going to be equal to minus 1 by lambda into e power minus lambda x minus 1. So this is, I'm going to write it like minus 1 by lambda e power minus lambda into x minus 1, which is uv. Minus integration of v. V is minus 1 by lambda e power minus lambda x minus 1 into du. Du is going to be 1 into dx. So this is the entire term. We have the common term which is 1 minus 1 by lambda. So I'm going to take it outside. And we have to substitute the limits here, I forgot it. 1 to infinity, and this is going to be from 1 to infinity. So which is going to be x into e power minus lambda x minus 1. It's varying from 1 to infinity minus integration of 1 to infinity e power minus lambda into x minus 1 dx. So it's going to be minus 1. I'm going to cancel this term. It's going to be minus 1 into, and substituting the limits, it's going to be 0 minus 1, and this term is going to be minus of minus 1 by lambda e power minus lambda into x minus 1. Again, the terms vary from 1 to infinity. So this is going to be minus 1 to minus 1 plus 1 by lambda. Again, it's going to be 0 minus 1 over here, so it's another minus 1. So it's 1 plus 1 by lambda. This is the equivalent of 1 to infinity x into lambda e power minus lambda x minus 1 dx, which is equal to e of x. Next, we need to find the variance of x. So we need to find the e of x squared term so that we can substitute and find the variance of x. E of x squared is going to be integration of, again, from 1 to infinity x squared into lambda e power minus lambda x minus 1 into dx. So again we have lambda, which is a constant, 1 to infinity x squared into e power minus lambda x minus 1 into dx. Again we have to perform the integration by parts. This is u, this is dv, and we will have the term equivalent to, this is x squared into minus 1 by lambda e power minus lambda x minus 1. The entire term, the limits are from 1 to infinity minus integration from 1 to infinity minus 1 by lambda e power minus lambda x minus 1 into du, which is going to be 2 times x dx. So again I'm going to take the 1 by lambda outside, so it's going to be minus 1. So taking it outside and cancelling with this lambda, it's going to be x squared e power minus lambda x minus 1 varies from 1 to infinity minus 2 times 1 to infinity x into e power minus lambda x minus 1 into dx. And as you can see, this term, we have already calculated the value for this term. It's equal to 1 plus 1 by lambda. So I'm going to substitute it directly. Stop. Leaving as a duster. So I'm going to substitute the value of that directly. And we know this value is going to be equal to minus 1 when we perform the limit substitution operation. So it's going to be minus 1 minus 2 times by lambda 1 plus 1 by lambda. Is equal to 1 plus 2 by lambda plus 2 by lambda squared. This is e of x squared. So we need to find variance of x. which is equal to e of x squared minus e of x the whole square. So I'm going to just substitute the values. So on simplification, so this 2 by lambda, this 2 by lambda gets cancelled, this one and this one gets cancelled. It's going to be 2 by lambda square minus 1 by lambda square, which is equal to 1 by lambda square. That's solved.